All right, it's cooking. Okay, so you've had me before? You have not had me before?
In your class?
Yeah, you've never been in my class, but you've just had me online, right?
No, I don't.
You took five. You took 835.
8:35, yeah, you were the.
Yeah, so I was, but online. Okay, gotcha. So just some the way I kind of run my classes, I record all the lectures. So we will. I take more breaks now because we have a new accreditation thing. So I take a break pretty much every hour, and we take because I used to go 2 hours, then like a 5 minute break, and then 2 more hours. So now we go like an hour. We take a 10 minute break, and blah blah blah. So we'll probably end up going 3.5 or 4 hours pretty consistently. I record all the lectures, so each lecture will be broken down into 3 individual videos I put up on YouTube, so you can go back and watch them or whatever to help you put you to sleep. So I will spend a little time reviewing some of the stuff that I typically teach in 535, just so I can get a feel for some overlap of kind of what you learned in Dr. Locklear's class versus how I usually present stuff. After talking with him, I think we're going to be fine. I don't think there's going to be an issue. I think you learned everything you were supposed to learn. So, but we'll figure it out. I'll unlock the syllabus during our first break or whatever, but generally speaking, we do grade breakdown just to give you an idea. So we'll have 7 programming assignments. We'll have 7 papers. So every week you'll have a paper and a programming assignment. So
paper will be about 3-4 pages, or it is up to us.
No, it's going to be 10 to 12 pages.
Every single assignment. It's like every single project.
And now we're down to 2. Now the papers are like 2 to 3 page papers. You can double space them. That's fine. It's mostly there's really two reasons for the papers. One is for accreditation. We're getting ABET accreditation, so it means your degree will mean more. So that has a writing component to it to get that accreditation. And also, being non-English speakers, natively, writing is something that you need to practice, right? It's going to be a weakness if you're dealing with English speakers. So the more practice we can get, the better. It's kind of the punchline. Okay, so 7 programming assignments, 7 papers, and then we have a final exam. So programming assignments and papers are each worth 60% of your, total are worth 60% of your grade. The exam is worth 40% of your grade. So this is, if you want to break it down, you can say 30%, 30%, and then 40%. All right. The exam, sometimes I do the exam in class. Sometimes I do the exam as an online exam. This semester, I think it'll almost certainly be online. Do you know, is the last week of class the week before final exams or the week of final exams? For undergraduate?
Around, I think, mid-December somewhere.
Yeah, let me.
It will be like
Here we can.
last 2 weeks of December.
We can look it up here. All right, so that's week 1, 2, 3, 4, 5, 6, 7. So week 8 would be the 14th. Okay, yeah. So that's during our final exam week. So week 8 is when you'll have your exam. I will be on a cruise. Okay, so I'm going to be in the Caribbean during that time. This was planned like 2 years ago. It's my brother. We're going with my brother.
So
Yeah, and then I stay down in Florida for. Then I stay down in Florida for 7 weeks after that.
Oh.
So,
7 weeks?
yeah, I have a condo down there. Yeah, I'm a very avid golfer, so I'm not putting up with Wisconsin winters. But usually I go down there the second week of December. But this year, because of this cruise, my brother booked it for his 2 kids. It's the week of final exams. He must have gotten a good deal on it 2 years ago. So
That's really
So-
great. And,
that only impacts us for the final exam. So we'll just make it online and.
so how long it will be, like the cruise by itself? Like
Oh, seven days. Yeah. Normal
Normally
cruise.
7 days is okay, or if you go more than that, then it becomes
Most of the Caribbean cruises are 7
7
days.
days.
Yeah.
It might be becoming.
And I've been to all the islands. Like,
I know.
they're all the same. It's all the same crap.
Oh, but it is still entertaining on water. And
I like the boats. So we go on different ships. We like to check out the ships. So I eat and drink.
And
Heavily.
this next week I might be leaving a little bit early because I will be getting engaged on 5th of November.
You're getting engaged?
Yeah.
Oy.
And then I will be in March or April of for spring. I'll be getting around married at that time.
Where? Over here or over there?
Yeah, I will be getting in Minnesota.
Oh, Minnesota?
Yeah.
That's not a destination wedding.
Actually, my brother lives there, and this girl also lives there.
Have you met the girl?
Yeah, of course. I talk every single day.
Well, I got invited.
Yeah.
The guy who gave me this bracelet thing. Yeah, he invited me to his wedding, and his wedding's in India. I get to go to Bangalore, India.
Oh, Bangalore.
Yeah, but so I'm not invited. First of all, I'm not invited to your wedding. Secondly, it's in Minnesota
So no, still
in the winter.
No, I mean it will be in April or May.
Oh, April or May. Well, wait, I mean, which is still basically winter in Minnesota.
Yeah, this will be the beginning, kind of. It will be still a bit cold. But still, we have to arrange 2 weddings in India. Usually we do 2 kind of weddings, one from the girl's side and one from.
Oh, so you'll have a wedding in India.
No, I will have a wedding, but it will be like it will be north of Kashmir, but it will be I think later after 6-7 months. But here
In India.
Yeah, here.
Am I invited to that one?
Here.
Because I want to go to India. Is what I.
Of course. that is the only reason I am talking to you about it.
What's this?
He told that location would be Kashmir, where he would have his second wedding kind of thing.
Yeah.
So that's the core region, which you're not very good with.
That's cold. That's a cold region.
Yeah. It's
No.
in the northern parts of India.
Yeah.
So it's
Oh, so that's like by the Himalayas, by the mountains.
It's on the Himalayas, but it is called as heaven on earth. But you will see.
Yeah, it's very beautiful.
Yeah, but it's cold.
It's cold.
It is not. It is around
You can see his
winter
pictures on
months,
Facebook, they're
3-4
all
months.
heavy jackets.
But you
Won't
can
be
still.
as
School as you know.
I mean, we've covered. I'm a golfer.
Yeah,
I'm an avid. You don't golf in the Himalayas. You
yeah.
go to Mount Everest in the
We have
Himalayas.
such a good golf course there. We have even in one golf course, we bought land. We bought the soil for that golf course from England.
Okay.
And the plains, it was like taken to the particular.
Yeah, because you don't have dirt there. It's all mountains and rock.
Yeah, they are.
You need to bring in the dirt.
We have.
It's like Arizona.
But it is really beautiful. I would love to take you because if you will even search Kashmir,
Yeah.
it is in Himalayas. One part of it is like all the broken piece of wood.
Can you see Mount Everest from there?
We can not.
Of course not. It's like a big state.
No, if you.
Well, Mount Everest is the biggest mountain in the world.
But
Yeah.
if
If
You
go
can't see
to
the peak
Ladakh-
from a distance?
Yeah, if you go to the
if you
Ladakh.
even go to the peak, you can see the ground. It's called-
Oh, is that high? Because you can't see the ground.
First of all, I
It's
have
covered
to
in
ask a
clouds,
question.
so it's
Have you
not
been
possible.
to Kashmir?
I saw some photos.
So no, I mean, I've been to the moon then.
I have been to the mountains.
I've seen photos on the
But
moon.
you can assume that the weather there would be like cloudy all the way because it's the highest mountain right now.
Yeah.
You can't see the ground. from
So
there.
is it Hyderabad's in the south, right?
Yes.
It's all up in the south.
So they have golf courses there.
Yes.
Yeah,
Plenty
of
of
course. Hyderabad,
Yeah, that's-
Bangalore, they are pretty
So that's
much
where I want to
cities.
go, right?
Yeah.
That's right beside Bangalore.
Yeah.
Like
It is
maybe,
Mumbai
2 to 3
is
hour
really
drive.
good city. The film city is there and everything.
So I can go there and I can play a lot of golf and eat a lot of curry.
Yeah, lot of curry. It's
I like a lot of curry.
Lot of cars too
Lots of cars.
on the road, and there will be all buzzing and honking
So busy city.
all the time.
It's a busy city.
Yeah, all over India, you will find.
Well,
it.
I mean, you got India and China both have like huge population densities.
India have more
You don't wanna
density
eat too
as
many
per
curries
ratio
over
of the
there.
land.
What's up?
You don't want to eat too many curries over there. It's gonna mess up your stomach.
I know. I was in. My wife and I went to Israel in June with our church, and that place is the hottest place I've ever been to in my life. And here's the thing: is so it was like 98 degrees Fahrenheit there, which doesn't sound that hot, right?
Okay.
but everything there is rock.
Oh, yeah.
So it's like a pizza oven, right? The ground is giving off heat. And so there, Mediterranean food, the kind of the staple is hummus, right?
Oh, hummus, yeah.
And it was really good. That was like the best thing. But
chickpeas.
yeah. But oh my gosh, the American stomach can only take hummus for about 2.5 days straight.
After that, it is
Then things start going south and east and west,
Yeah.
a little bit north. Are we already a little bit more entertaining than Dr. Locklear's class?
Yes.
All right. So in any case, programming assignments and papers will be 60% of your grade. Final exam is 40% of your grade. You'll know what's on the exam ahead of time, and it'll be like an online timed thingy. It's the normal grade breakdown thing. Generally speaking, you've had my classes before. I grade on competence. So, if you work hard and you keep doing your homework assignments and don't cheat on them and all that other good jazz, you're probably going to get through the class okay. Programming is hard. So, chances are you're going to suck at it at first until you just keep getting better and better and better. So I want you putting in the time. And what I do with everyone in my assignments, you'll see it on the course, is I have this self-evaluation that I have you turn in with the assignment. Because sometimes you'll be working on a programming assignment, and when you submit it, you have very little to show, but you might have spent 15 hours on it. But you have little to show, right? Like, okay, I spent 15 hours on this assignment, and I have nothing. So the self-evaluation is your opportunity to tell me kind of what happened, right? What your experience was, what works, what doesn't work, where did you run into problems, how did you try to solve the problem? Explain to me your voyage to submitting nothing or submitting something partially done, so I can give you some partial credit. Make sense?
Yes.
All right. So that's the gist. All right. Questions on the grading crap stuff? All right. So pretty straightforward. I'm pretty laid back. So for example, we have. Obviously, you probably dealt with it in some of your other classes, big plagiarism issues and stuff like that. I'm not going to sit there and look. I don't care. I don't want you to cheat, but that exam's worth 40% of your grade. I'm going to find out if you learned this stuff or if you copied from somebody else, right? So that right there is my plagiarism detector, right? So I want you to work together on your programming assignments specifically. I mean, because you're going to hear me explain stuff. You're going to see me do stuff, and I'm going to make it look easy. So most of what I do in here will be live programming. I don't know how Dr. Locklear did it in class, whether it was lecture or not, but I do a lot of live programming, and you'll see it work, and I'll do different things and have you try to help with stuff. So when you see me do something, it'll look like it's easy. When you go to do it, they'll introduce a whole bunch of errors and bad things will happen and all sorts of stuff like that. So, I want you to have a support group. So I'm fine with the three of you getting together and working on your programming assignments together. But work on it with the goal of doing well in this exam.
Learning, yeah.
That make sense? Yeah, I'm not going to sit here and knock you on points because your programs look the same. I don't care. Okay, as long as you learn the stuff. That's my job as a professor, is at the end of the semester, I have to give you a grade based on how well you've mastered the material. Make sense?
Yes.
All right, so, and I've been doing this a while. So this is my 17th year teaching. So not my first rodeo. Are you even 17 yet? How old are you?
I'm 32.
22.
No, 32.
Oh, 32.
Yeah.
How old are you guys?
I'm 31.
31?
23.
23.
Most of the
30,
Indian-
23. 2-3, right? Oh, so he's the young one.
Yeah, he's the youngest.
Yeah.
I think
So I started teaching when he was 6.
So you have the experience equal to his age.
Okay, so let's jump into some stuff. So I'm gonna be having a fairly direct conversation with you for a little bit. I know he's had my content, I know he's had my contact. So I'm going to kind of zip through some stuff, almost doing a 535 crash course in maybe the next hour. So the hope is most of it's a review for you. But where there's not review, if I show a topic on here that you aren't familiar with, tell me, and we'll just cover it. Okay? Like I said, Dr. Locklear has his way of doing the class. I have my way, and I'm usually the one who teaches it. So it's, we're not, you know, I've been here 11 years, but we're not in, I don't know what he leaves them off with. So that's what we're going to discover over the next little bit. Okay, so I'm going to start spitting some slides out here, and we'll start building some stuff up. So I usually kind of start things off with, you know, what is programming? So programming is effectively telling a computer what to do. Okay, and I'll put these slides up on.
You get these stuff, right?
Yep, I'll give them to you. So you'll have the videos, and I'll put the slides up on there so you can. I'll share it so you can link them, so you don't have to write everything down. I said I want it to be fairly interactive. So what's programming? It's telling a computer what to do. That's why we program, right? Okay, we got this thing sitting in front of us, this alien, okay, that speaks a whole different language than us, and we want to tell this guy what to do. Okay, and how do we accomplish this? So that's our programming languages. Okay, so what's a programming language? Programming language is a tool that enables us to solve problems the way we already solve them and ultimately tell a computer what to do. All right, so this is really the power tool that is a programming language. So when we think about programming languages, I really want you to think about like a chainsaw or a power drill, something like that. Something that makes life a lot easier for us. So if you want to chop down a tree, okay, we can go out there with a butter knife, and with enough effort, right, we can get that tree down. Okay, it's going to take some time. Okay, but if we have a big old honking chainsaw, that tree is going to come down, right? Okay, it's a power tool. So rather than us being on an even fight with the tree, what programming languages do is they gives us that chainsaw. So we're not on an equal footing with the computer. We have the advantage. Okay, the programming language allows us as human beings to solve problems the way we're already used to solving them. Okay, that way we can then go and not have to relearn the way to think. And instead, the language lets us leverage mostly the way we already solve problems and translates it into the alien language that the computer understands. Make sense? Okay. Because this dude is stupid. Okay? Computers, they only do what we tell them to do. All right? So at the end of the day, I want to talk about the nature of the CPU. Okay, what's the CPU? Okay, central processing unit, brain of the computer. Okay, that's so. If you were to crack open the CPU and look inside of it, what would be in there? What would you find inside the
Transistors and capacitors.
transistors, capacitors, wiry stuff? Okay, so if you had to describe how a CPU is the brain of the computer, how it does its job,
CPU.
what would you?
It just processes normal arithmetic and logical.
It has some instructions.
Addition and subtraction, going to gates.
Okay,
That's it.
so we have instructions.
Yeah.
So you mentioned instructions. Okay, you talked about gates and stuff,
Yeah.
right?
It receives the information and processes it and takes whatever it has to find, a memory slot or something to find, and then it sends a request back.
Okay, so I like to think about CPUs as kind of like a bucket filled with magic tricks. Okay, so you mentioned instructions. So our CPUs know how to do a bunch of stuff. Okay, and so they know how to do a whole bunch of little magic tricks. They know how to move something from here to here. They know how to take this hardware register and increment its value by 1. Little tiny moves, granular little magic tricks that solve a very tiny problem. Okay? But there's so many magic tricks that a CPU knows how to do that if we can tell the CPU to do this, then this, then this, then this, then this, something real has actually been accomplished, even though each of those individual steps seem pretty small. Okay? Now you mentioned gates and stuff. Okay, so when we think about how the CPU implements those magic tricks, instead of it being written in software, like we're going to be doing in here, it's written in hardware. Okay, so hardware, gates, transistors, all that crap, that's effectively programming with a soldering iron. Okay, you know, you're creating a computer program, but instead of it being software that you can backspace on, you're gluing stuff together with metal and putting electricity into it, and that's your logic that flows through. Make sense? Okay, so the CPU is a collection of these circuits, and each of those circuits solves some small problem. And if we ask the CPU to solve a whole bunch of small problems in a row, a larger, more complex problem ultimately gets solved. Okay, so the goal of our CPU, so we're going to say this guy is a collection of magic tricks, each of which is a hardware circuit. Good enough. Each magic trick is granular enough to solve a simple problem, but powerful enough to be combined with other magic tricks to solve more complex problems. Make sense? So that in and of itself, if we were, so for instance, right now I'm teaching a computer architecture course in our Masters of Computer Science program. So in there we talk about how CPUs are built, you know. So imagine just this last paragraph here. If you're Intel and you're designing a processor, how difficult is that? Forget about the magic trick implementation. How difficult is it to create a list of magic tricks that does enough to be useful, but doesn't do too much, but also doesn't do too little? Kind of capturing that instruction set that allows you to solve all general purpose problems. So when new processors come out, what we typically have is we typically get more magic tricks tacked on to the old instruction set, because we've realized we usually get some more real estate because we've gotten better at putting circuits close to each other, so we can fit more stuff in the same space. Okay, so we get a little more real estate on there, so we can put some more magic tricks on. So now we have more magic tricks, and maybe those magic tricks help us either solve new problems, or maybe common problems are now combined into a more complex single magic trick. That kind of stuff. Go ahead.
I think they're not most circuits are not added for solving more problems. They're just added to solve the same kind of problem, but in a parallel way.
In a more efficient way. So if previously you would say magic trick 1, 2, and 3 to solve a problem, you might get a new magic trick that solves the same thing, but it might be magic trick 4 or magic trick 4, 5 that ultimately makes this combination of 3 things that you might do often. We might turn that combination of 3 things into one thing. Okay, so now it's fast. Okay, it's less generic, but maybe it's something that we use all the time, so it's really important, and we make it fast, and we have the space for it, right? Because anymore, typically we don't care unless it's mobile. We don't care too much about power consumption. You know, if we're dealing with mobile processors, we care about power consumption. If we're tethered to the wall, who cares about your power bill, right? It's kind of the design premise of this. Okay, so that's what the CPU is. So ultimately, as a programmer, what we're doing, when I say we're telling a computer what to do, so we're sitting here on this guy here. Why do we program? It's because we want to tell a computer what to do. When we're talking to the computer, we're talking to the CPU. We're talking to the brain. Okay, so if I boss you around, I'm talking to your brain. You're absorbing what I'm saying and you're reacting to it, right? When we talk to the computer, we're talking to the CPU. Okay, so we're issuing commands to that CPU. Now, we have 3 types of programming languages. We have low level, high level, and machine language. All right, so machine language, this is our 0s and 1s. Okay, not for human consumption. None of us want to have the 2-button keyboard. Just tapping out 0s and 1s all day long, we would go insane in about 15 minutes, right? And probably have thousands of errors. That's not for humans. We can't handle that. Okay? Now, a low-level language, so ultimately, at the end of the day, that's what the CPU gets. Okay? And I'll show you a little translation here. So let me finish these things here, and I'll kind of show the steps at a really high level. So a low-level language has a one-to-one relationship with the CPU. So that means each command relates to a single instruction on the CPU. Okay, so we just talked about that the CPU is a collection of magic tricks, and each one of those is very granular, does a little tiny thing. In assembly language, every line of code we write translates into one of those tiny things. So, as an example, I typically will show like a hello world Linux assembly. That'll be. Actually, let's do hello world 8086 assembly. I prefer that one. Oh. Okay, actually, I'm going to do the Linux one. It looks more daunting. The DOS one's actually kind of shorter. This will drive my point home. This one. Okay. All right, so this is hello world in assembly language. Okay. Where if we were writing in Java or something like that, we would just do system.out.println hello world. Done. Pack up your bags and go, right? Okay, no, not here. So this kind of gives us an idea of how operating systems work with the CPU. Okay, so these guys, EDX, ECX, EBX, these are what are called hardware registers. Little variables made of hardware. So super, super fast little memory locations that live on the CPU. All right, so don't worry too much about that for a second. Just these are storage locations. Okay, now down here we have a couple of variables. So we have hello world stored inside of a variable called message. And this guy is a data byte. So this is we're going to talk about arrays here in a little bit. So this is actually the base address of a character array, and we walk on the offset of that guy. That'll make more sense later. Don't worry about it. Okay, but this is our string hello world. This guy is the length of that string, because strings in assembly language do not know their own length. Okay, so we have to store both those pieces of information. Now, to ultimately print hello world to the screen, and remember, what we're looking at here is effectively us telling the CPU exactly what to do, one line at a time. We're not speaking zeros and ones, but we are speaking a low-level language here, a one-to-one relationship. We are talking to that CPU with little tiny baby steps.
These are something called as mnemonics, right?
Well, yeah, this assembly language would be a mnemonic, right? So, it's more English-like, something more familiar to a human being than zeros and ones. Okay, but ultimately, this command right here gets translated. It gets, right, when it gets assembled, it turns into zeros and ones. All right, so this is, go ahead.
I thought that was like part of computer architecture.
Yeah, it is.
So it's included in 537.
No, I'm kind of giving you just the high level of this guy. I'm just giving you the background. Just the example. No. Just the example. Yeah. I'm giving you this definition of low level. Filling in some gaps, okay? All right, so what am I going to do? The first thing we're going to tell the CPU to do is move the length of our string into this place for some reason. Next thing we're going to do is we're going to tell the CPU to move the string itself. This is actually the base address of that string into this place. Fine. Then we're going to tell the CPU to move the number 1 into this place for some reason. Then we're going to tell the CPU to move the number 4 into this place for some reason. Okay? Now let's talk about why we did those 4 things real quick, because this gives us an idea of how software works with the operating system and works with hardware. Okay? So what we effectively did in these 4 lines is we staged 4 values. Okay? I remembered the length of our string in one place, and it happens to be a very specific place. I put the length in EDX. I put the string itself in ECX. I put the number 1 into EBX. That 1 relates to where do I want to write this to? I want to write it to standard output. That's what the 1 is, the screen. Okay? So we're storing randomly the number 1 here, but the operating system is going to know to look in that place to find out where you want to write it. All right? Then we're staging a 4 here in EAX. This is actually the most important one because this 4 relates to the system call that's part of the Linux operating system called syswrite. So built into the Linux operating system is the ability to write a string to the screen. And it happens to be system call number 4. All right? So what we're doing here is we're staging the value of what we want to do there, and then that guy takes 3 parameters. It's like a function.
So it is kind of the machine language.
This is machine language. Yeah.
When we
Yeah.
are talking to the memory, what
Mhm.
you have to do rather than
Right,
just
but we have to have knowledge here. The reason that we moved these 4 things into those 4 registers is because we knew that Linux is going to look for those 4 things in those places. Okay? The very first thing Linux is going to do is it's going to look inside of EAX to find out what do you want to do. Once it finds out that you want to do a syswrite, function number 4, it's then going to say, okay, well, I expect 3 parameters. I need to know where I'm writing it to. I need to know where's the base address of what I'm writing, and then I need to know how long it is. Okay? I need those 3 pieces of information in order to do my job. And the Linux API says, I'm going to look in EBX to find out where you want me to write it. I'm going to look in ECX to get the base address of the string. And I'm going to look in EDX to find out the length of the string. All right? So we stage 4 values there, and then right here, we interrupt the CPU and say, Linux, take over. What does Linux do? It jumps to EAX first and says, okay, what does he want to do? He wants to do a syswrite. Okay, look in those 3 places, get the 3 values you need, and then he does his thing. Writes hello world to the screen. All right, now we come back. We're back to our program here. We move into EAX. So notice EAX is this register that Linux expects us to put in what we want to do. So we move 1 in there, which is sysexit. That's finish the program. Okay, so we move sysexit into EAX, and then we call Linux again. Linux will go in, look at EAX, see a number 1 is in there. EDX, CX, and BX still have crap in them. But because this function doesn't require any parameters, Linux isn't going to look at it. It doesn't matter. Okay? So punchline is this seems like an awful lot of work to display hello world to the screen.
to even remember the locations in this form, you have to remember those what EDX to what we have.
You would be looking at the Linux documentation for the assembly language for Linux. It would tell you if you want to do a syswrite, here is the 3 values I need. This is where I want you to put them. That's how parameters are passed. Okay? Okay. But so we can all agree this is tedious, right? This isn't, I mean, well, it is kind of fun from an academic perspective, but you wouldn't want to do this all day long, right? Okay? But it's interesting because we're seeing how it actually is working under the hood. So what we're looking at right here is this guy, these low-level languages. Okay? Certainly, this is easier to look at than a wall of 0s and 1s. All day long, right? You'd rather look at this than look at 0s and 1s. Okay? But we'd rather look at Java than this, or C#, or Swift, or C++, whatever. We'd rather look at all those over this. Okay? So we have low-level languages which have a one-to-one relationship with the CPU, so each line of code translates into one of those magic tricks on the CPU, versus a high-level language which is a one-to-many relationship with the CPU. Each command relates to multiple instructions on the CPU. Okay? So, as an example, if we're connecting some dots here, in Java, if we say system.out.println, it means all of that. One line, lots of stuff. One-to-many relationship. Make sense? Power tool, chainsaw, power drill. however you want to think about it. Okay, that connects some dots. Okay, so that's the world we're swimming in here, is this world. Okay. Now, just out of curiosity, did you talk about the stuff at this level in your? I tend to go pretty detailed.
This is good.
So this fills in some blanks for you. That's good. Yeah. So I'm probably one of the few people who tries to go at this level. So it's nothing against him. He probably went at the correct thing. I'm just more of a freak show. Because I want you to be able to appreciate where we came from. Okay. So in any case, and the other thing is he teaches a lot of different classes, and I teach programming, and then more programming, then even more programming. I spend a lot of time programming. All right. So 3 different kinds of programming languages. Computers ultimately like this one. This is our middle guy that we'd like to avoid. We like this guy, the high level. That's the sweet spot for us. That's our chainsaw. Okay? So we're going to try to stick to that guy most of the time. Okay. So, again, programming. Tell a computer what to do. Programming languages. That's our tool. That's our power tool. And those guys come in some different flavors. We like the high level flavor as people. Okay? We want to use the chainsaw, not the butter knife, to cut down the tree. Okay? So that means we need to identify languages that are chainsaws.
Yeah.
Make sense? Okay. So, next slide I'm going to throw in here is how do humans solve problems? Okay? We remember stuff. We ask questions. And repetition. All right.
We go to Federal Bank.
Say this again.
We go to Federal Bank.
He says we go to bank to solve the problems.
Oh,
To take the money. And
take
solve
the steal the. Oh, so at the end of the day, you're saying that money solves all problems.
No, on a whole level, I took Federal Bank, so
Okay.
Most of the problem.
So now, when we think about, so usually the question I'll ask first day of class in 535, since I'm kind of reviewing that, is I'll say, how many of you got to class today without bumping into any walls? Right? And you get 1 or 2 smart asses that raise their hands, say, oh yeah, I bumped into some walls, blah blah blah. But most of us, we came in from the parking lot, right? And we navigated these hallways. We didn't bump into anything. How many of you were texting while you were walking? Done it before, right?
Yeah.
Okay, yeah. So it's not even worth your full attention. As you're walking to class, it's not worth your full attention to do it. Okay? Well, then I'd ask you, well, how did you get to class without bumping into walls? Well, a normal human being's response would be, oh, I just did. Right? I just did. Started walking, didn't bump into walls.
I've been doing it for years and years.
Exactly. And that's really that's the difficulty with programming. The reason why computer programming is difficult for us is human beings are so good at solving problems that we find it very difficult to articulate how we solve problems. All right, so one of the things that you would have talked about is algorithms, right? What's an algorithm?
step-by-step instructions.
Step-by-step instructions, set of instructions, a recipe, right? So set of instructions, recipe. So, we would follow an algorithm for making a lasagna or a nice spicy curry, right? Yeah, I like with the coconut milk with the yellow curry paste.
Oh, it was good.
Oh, I like that stuff.
Oh, it's really good. Coconut makes it tasty.
I know, it's so good. I went to, where'd I go? Some Indian restaurant.
Anmol?
Huh?
Anmol?
Yeah.
Anmol is. There is an Anmol Palater too. The name of the.
Okay.
They made it special on there, and it is not rice or bread or anything. It is just meat. And it would be chicken.
Oh yeah, I got that. The combo one.
Hot one, yeah.
Yeah, that's what I got.
It is really tasty.
Yeah.
We usually go there.
Yeah. Have you been to this place?
You're just talking about one restaurant over there.
Anmol is the best one. I have been.
Well, I don't know.
Have you
I'm
been to
He comes
Chicago?
from Chicago.
well,
so
I've been to Chicago. Oh, do you,
Zoom in
hold
there,
on. Oh, do you
find-
drive up here from Chicago for class?
Normally.
Yeah.
I sometimes stay in Chicago, sometimes in Milwaukee.
Oh.
Got a lot of friends. So
Because I'm a fan of Portillo's.
I don't know what that is.
You don't know what Portillo's is, and you're from Chicago?
Oh, I just ate pizza, so I don't know how to cook it.
Portillo's is a restaurant. It's like Chicago style food, like hot dogs and Italian beef. Yeah, see, he's making fun of me. He's like, oh, you're just talking about one restaurant. He doesn't know about Portillo's. They got like 50 locations in Chicago. Yeah, that shut him up quick. So there's a good Indian place in Chicago?
Yeah, they're like the whole, most of the street is covered with all Indian restaurants. So if you come over there in weekends, you can't find parking, I'm sure.
Well, actually, there's an Amol. There's an Amol in Chicago,
Yeah.
right?
There is so many other restaurants, better restaurants than even
Yeah.
Anmol. It is one street which is called, I think, the
Diwan.
Diwan. All
Divan?
Indian, yeah, Diwan. It
Okay.
is all Indian food.
So it's
all
like Little
Indian
India.
food. Yeah.
It's Chicago's Little India.
If you
Yeah.
just zoom in there with that location on Google Maps, you'll find it in there.
But is it real Indian food or is it like crappy Americanized
When I
Indian
came
food?
from India, it didn't feel like real Indian, but that's like
Now it's the best you can get?
Yeah, that's the best I can get.
Yeah, I gotcha.
No, but still in America, this is the biggest market of Indians.
Yeah.
They have all the businesses, whatever India they just. There are so many Indians who, even from our campus, so many people want to live there because they get their food, they get the people.
I gotcha. Yeah, I went to Amol the other day with Shiva,
Oh,
and he ordered, and it was spicy and stuff. But I mean, I like spice. I mean, you don't get to be my size and be all that picky. It was pretty good.
yeah.
Yeah, I would.
Shiva came to my
Huh?
house and
Shiva gave you a treat?
Yeah. Is that
yeah, I
bad?
saw the
No, I was first in the line, I thought. So,
Oh no, I went to breakfast with him this morning.
Yeah,
I got
he
this.
Posted the pictures.
Yeah, I got this. He gave me this morning. I bought him breakfast this morning because he bought me lunch the other day.
okay, good to know that.
Yeah, he was saying it is too much breakfast.
Yeah,
And they were stable.
seriously.
Yeah.
All right, so algorithm, set of instructions, recipes, blah, 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 right? Okay, so the end of the day, if we're going to tell a computer what to do, we need to have an algorithm to do it. And the way we got onto food there is I was going to say something like, if you're going to make a lasagna, you're going to make a curry, there's a set of instructions you have to follow in order to do it, right? You can't just throw everything into a bowl and say we're good. Okay, you do some simmering, and you add some ingredients, you do some more simmering, and you add some more ingredients. There's a step-by-step instructions to do it right. Okay, and it's important that you follow them. Okay, so when we're cooking something, we might use a recipe. When we are tying our shoes, we use a recipe. Now, do we all have tieable shoes in here?
Yeah.
We all know how to tie shoes? We can use that as a baseline? Okay. So how many of you use a cheat sheet when you tie your shoes? Do you pull out a little note card and say, okay, I'm supposed to do this, and then you cheat, right? Or do you just remember?
We just remember.
Actually, do you remember? Or do you just do it?
We just do it.
Do you even think about it when you're tying your shoes?
Or unconscious mind just
It's
does it
our-
without us even
Yeah.
knowing.
You don't sing the little song, right?
You don't even
Muscle memory.
see, you don't even
Yeah.
look to it.
I mean, when you're a kid, you learn the song, right? I don't remember what the song is, but isn't it like bunny ears or something like that, and like through the loop and like that.
Every night,
Okay, it's
you
a,
have to go to sleep.
yeah. So, but the point is that now you've done it thousands of times. You don't even think about what you're doing. You just do it. That's why human beings have problems becoming programmers. We have trouble slowing ourselves down. Okay? If I asked you to write step-by-step instructions to tie a shoe, that's a pretty simple task, right? To tie a shoe. We would struggle with that.
Right.
If I'm going to have you give those instructions to somebody who has no clue what tying a shoe means, it's going to be difficult for you to get detailed enough for such a simple task as tying a shoe. So now imagine if you're trying to explain to somebody how to walk from the parking lot to class without bumping into walls. When you're walking down the hall, how often are you glancing around? looking in front of you, making sure you're not going to hit anybody. You're walking down the hall. Am I going to fall over? Am I going to fall over? Am I going to hit somebody? Am I going to hit somebody? Am I going to hit somebody? Am I going to fall over? Constantly. Now, we would go crazy if we actually heard ourselves talking to ourselves, right? We all know that we're asking tons of questions, right? As we're walking down the hall, we know that we're constantly making little balance adjustments, and our vision is picking up on stuff. We shift our weight ever so slightly so we miss a corner or miss a person, that kind of stuff. But it all happens without us even being really aware of it, right? Because we're too busy texting. Human beings are so good at solving problems that we have trouble slowing ourselves down so that we can write algorithms. This is the skill to program, not Java, not Linux, or not C#. The languages doesn't matter. Okay? It doesn't matter. Okay, so all of you guys in here speak at least 2 natural languages, right? At least 2.
Yeah.
Okay, because I'm going to go out on a limb and say all of you don't have English as your first language, right? Okay, so it's how many of you are Urdu? Any Urdu? Urdu? Okay, you're from that state. So this morning we got a phone call at breakfast, and I answered the phone, and I was speaking Urdu.
Oh.
But apparently the guy on the other phone was speaking Telugu?
Telugu.
Yeah.
Telugu.
Oh, yeah.
Yeah, he was speaking another. Yeah, so I was speaking Urdu, so we couldn't connect.
Urdu is kind of Urdu and Hindi is kind of national language.
Yeah, right,
We
right.
have actual 2 national languages, which is Hindi and English.
Well, but isn't it because 6 states use Hindi, right?
Yeah.
There's 6 states that share Hindi. That's why it's kind of the natural language, the
Hindi
national
is,
language.
Kind of the general language
Right.
is there, and Hindi and Urdu is kind of sync right now. It is like already hybrided.
Okay.
Hybrid kind of
Yeah, so I was speaking Urdu to this guy on the phone, but he didn't understand me because he spoke the Telugu.
Telugu.
Yeah, that guy. He spoke that one.
I have I have Kashmiri. Like it is Kashmiri for them. There is Telugu, the local language. It is kind of 350 plus language, and even 1,600 dialects in India. It's like
Man.
we cannot even.
Now, what's your guys' base language?
Urdu.
Yours is Urdu too?
Yeah.
Oh, so see, we could all talk. What about you?
I got a mixture of Telugu, Urdu, and Hindi.
Oh, so you got Hindi, and what were the other ones?
Urdu and Telugu.
Oh, so you do. Oh, man, so you could have been the translator this morning.
Yeah, I could.
Yeah.
Next time, call me when ordering.
Yeah. See, what happened is the guy hung up on me
Uh,
because he called Shiva, and I said, "You want me to answer?" So I picked it up, and I was speaking Urdu. But as you might imagine, I don't speak Urdu. Yeah, so I was just making up stuff and doing clicks and crap. Yeah. So he hung up on me.
Who is that?
I was just making up stuff. But if I had him there, because he speaks English, plus he speaks the Telugu, whatever, and he speaks Urdu,
And it would have been
we could have just skipped the whole Urdu thing. I could just told him what I wanted to say, and you could have just said it to him.
Next time, call me. We can
Yeah.
work together.
You can hook it up. See?
Anyways, you usually
Yeah, we'll meet up at Portillo's.
he will find it by next week.
I can't believe you haven't been to a Portillo's. That's shocking to me that you live in Chicago?
No, I told you I move around.
Okay, so you've been in Chicago lots of times.
Lots of times, yeah.
And to your knowledge, you've never seen a Portillo's?
I just seen Little Caesars. That's it.
Little Caesars? So you've seen Little Caesars, but
That's my focus. Everything else I just avoid. Not bumping in anything.
so you're like a pizza fanatic. Specifically, you're a cheap pizza fanatic.
Yeah.
No, I got nothing against Little Caesars. Their pizza's pretty good for $5. I mean, but Portillo's,
I'll take a look.
Italian beef.
Yeah, we will be expecting you to have carrying something from potatoes.
Yeah.
next time.
Yeah, that's kind of what I'm thinking. Okay, so in any case, this is our challenge. Coming up with these algorithms, because we're too good at it. Okay? In real life, we do things that are ridiculously complex. Not bumping into walls while we're walking. I mean, I assume we all think about each and individual little tiny muscle twitch that we have to go through when we're walking down the hall. You think about, I gotta extend my calf, and that calf muscle has like 4 or 5 muscles in there, right? So you think about each of those individual muscles, or does it just kind of happen? There's 3 muscles. Okay, well, it just kind of happens. You don't think about those individual. Imagine the number of things that have to happen in order for us not to fall on our face when we're walking. And it's not worth our time to pay attention. We're texting. All right? We are really, really good problem solvers. So good that this is a problem for us. We have trouble slowing down to this part, and that's why programming is hard. Relative to walking in from the parking lot, writing the hardest video game that you could imagine is trivial. So pick your favorite video game. To write that software for that is trivial compared to walking in from the parking lot. But we think too fast. We can't slow ourselves down. We can't break it down into the algorithm. That's our challenge. That's what we need to get good at to become a good programmer. Make sense? The language doesn't matter. Okay? When you're speaking to your friends in Urdu, okay, or Telugu, Telugu. Okay, so when you're speaking to your buddies in Telugu or Hindi, okay, so you have buddies who speak Telugu, you have buddies who speak Hindi, you have buddies who speak English, right? When you're talking to them, they're all humans, right? All right? The exact same thoughts go through your mind, don't they? Because you're talking to a person.
It just comes out.
The words that come out sound differently. Sometimes you speak Java. Sometimes you speak C#. Sometimes you speak Swift. Sometimes you speak Python. But it's the same problem solving. Programming is programming, regardless of the language. Make sense? Okay? And you guys are uniquely qualified relative to me to understand that. I understand that concept because I know a lot of programming languages, but I only know one natural language. I mean, I know like enough Spanish to order at Taco Bell, okay? But I could also order at Portillo's. But you know, the punchline is I only speak one natural language, so I don't have that connection where I'm speaking to somebody else who's a human being using a different language. Well, except Urdu, I suppose. That gets me hung up on. All right. So, how do human beings solve problems? I like to break it down into these 3 steps. We use our memory. We have to remember crap. We ask a lot of questions. And we repeat stuff. Okay? So, when we're thinking about walking down the hallway, does Dr. Locklear explain it kind of like this in class? So, he uses a different concept? Okay. So, as we're walking down the hallway, we are, even though we're not aware of it, because we already explained we're really good at it, right? We are asking a bunch of questions. Are we gonna fall over? Am I gonna bump into something? Do I need to go a little bit right? Do I need to go a little bit left? And then based on that, the answer to that question, we react, right? We either shift our weight or whatever. So we're constantly asking questions. And it's so passive to us, we don't even notice, right? All right. So this is how people solve problems. So now to connect the dots, let me drop this down here. I'm going to steal this slide. I call this guy the mapping. So remembering stuff is done through variables. Asking questions is done through conditionals. And repetition is done through loops. Every single programming language will have facilities for these 3 things. We can remember crap by making variables and putting stuff in there. We can ask questions by writing if statements. And we can do repetition by writing loops, for loops, while loops, do while loops, whatever. Okay? If I showed you a brand new programming language you've never seen before, and you can learn how to do those 3 things, the syntax for those 3 things in that language, you can solve a pretty big classification of problems, right? You know, just like if you taught me how to say, where's the bathroom in Hindu, or Hindi. Hindu's the religion. Hindi is the language, okay. If you taught me how to ask, where's the bathroom in Hindi, that would allow me to solve a very specific problem, right? Okay, I mean, I'm not going to be able to really function completely when in India, but I'll be able to get to the bathrooms, right? All right, so if we can just learn a minimal skill set in a particular language, we can solve a whole big classification of problems using that language. That makes sense? Now, some languages lend themselves to some problems better than others. right? So sometimes languages have extra things built into them that make them more convenient for certain things. And my guess is, and I'm just guessing here, but so since you guys know several languages, my guess is that in some of the languages you know, there might be certain concepts that are more easily expressed in Urdu or Hindi or English, just because of the nature of the language. It might be easier to express a concept in one language versus another. It might not be that common, but there's, like for instance, I know that in Chinese, there's a lot of things that involve emotion that are kind of difficult to express.
Yeah, it has been happening recently when I was talking to my brother about this engagement thing, and I was not able to express in English.
Right.
So I said, let me talk in our own language
Sure.
first.
Yep.
Then only I can express what I actually
What you meant. Yeah.
with that thing. Is
Sure.
otherwise-
Sure. So
Yeah.
think about that like programming languages. Some programming languages lend themselves to certain problems moreover than other ones. That doesn't mean you can't solve I can speak English to somebody and get across most ideas that I would need to get across to a human being, right? So if I'm in a foreign country, I don't speak Hebrew, so I was over in Israel, I was speaking English to them, right? So they listened to my English, and
Not it.
but they knew what I was talking about. I was able to function even though probably only half of my ideas were getting across, right? Okay. So some languages lend themselves to certain problems compared to other ones, but they're all the same in terms of how they're built and in terms of the constructs that are provided for you. Every single one of them, 100% of programming languages have these facilities in them. Make sense? Okay. So that's my basis for programming. Is we have a language that mimics the way we already solve problems, okay? Because we're good at it. We're really good problem solvers. And our challenge as programmers is to get better at this, okay? Better at slowing ourselves down so we can break the solution to problems down into individual steps, okay? How do you tie your shoes? The answer is no longer, I just do. Now the answer is, I do this, then I do this, then I do this, then I do this. Once we get better at breaking problems down into those individual steps, we will get better at programming. That make sense? The language has nothing to do with it. So that's why when we have seniors in computer science, like undergraduates who say, oh, well, I'm pretty good at Java, but not C#, you just want to hit them. That's like it's a meaningless statement. It doesn't mean anything.
Because if the person knows how to break down
It's how to talk to a computer.
then he has to just how to say it in that language
Mhm.
rather than how to write it.
Yep. Yeah, it's a really important concept in order for us to put this all in context, what we're trying to solve, okay? Okay, so 3 types of programming languages, CPU. Okay. Let me do this. I'm going to quickly draw a picture here. I like to teach programming from the premise of I like to start in 1968 with the C programming language. Okay? It's not the first programming language, but we're going to say from our intents and purposes, it's the first programming language that matters to us as a modern programmer. Okay? So I'm going to go ahead and draw the whole chart out here first, and then we'll walk through it quickly. I'm really glazing over some of this stuff here, so you might think I'm going a lot of detail, but I'm not. So C++, Java, C#, C, Swift, actually, I don't want to say that. I want to say, we'll just stop there with Node.js. All right, and I'll kind of float out here to the side. JS for JavaScript. We'll float out here to the side. jQuery. I'm going to stop trying to resize and just deal with it. We'll float out here to the side. Angular. React. Okay. I'm going to label these guys. We're going to call these guys web languages. We're going to call these guys native languages. Okay. All of the languages that we see on this page came from C. Okay. C is their ancestor. So what you'll end up seeing is you'll see there is a lot of similarity in these languages. There are things from Java that look identical in C because they came from C. Okay, we'll kind of talk through some of that stuff as well. Okay, all of these languages are C-based languages. All of these languages are C-based languages. All right, now an important thing for us, whether you're a computer science person or an IT professional, something I like to explain. Actually, I'll ask you the question. So explain to me the difference between computer science and IT from your perspective.
Computer science is kind of like they have to do 70 or 80% of programming and 20% of little bit how to implement and things like that, where IT is how to implement things around. They do 70% of that. They can even purchase or do a contract with third party.
Yep.
And just 30 or 20% they do the programming.
Okay, so they're opposite sides of the same coin.
Yeah.
So IT, I like to say, is 75% using what's been created, 25% creation, okay, actually creating something new. Whereas computer science is 75% creation, 25% using what's been created. Okay, now in IT, you're effectively programming, just like we were talking with the CPU with those magic tricks, right? So we took all of these magic tricks, these circuits and things like that, we hooked them together in an interesting way and they solve a problem. IT, you take the server and you connect it to a router and you connect it to a switch in a lab and you have 40 computers hooked up to that switch. That's a circuit. It's a really big circuit. That's a circuit. You're programming. Same kind of problem solving, right? Yeah. You're still having to break the problem down to individual steps. So IT's creation 100% of the time. But in order to create a differentiation, the creation on the computer science side of things happens closer to the CPU. The creation on the IT side of things happens further away, right? Closer to the humans. That makes sense? Okay? So we're all programmers because we're all problem solvers. And programming is a synonym for problem solving, just like computer science and IT are synonyms for problem solving. Human beings, we're problem solving machines. That's what we do. We solve problems. We just have forgotten how we're solving them. We have trouble articulating that. Okay? So one thing I like to talk about here as it relates to technology is in tech we have a whole bunch of buzzwords, right? We have things that come out and they sound cool. And it's easy to get intimidated and say, well, you know, I don't know what React is or Angular or jQuery. These are all just words, right? With few exceptions, and this probably goes for everything, but I'm speaking from an expertise in technology. All of these buzzwords typically mean simple things, and they also all typically mean the same kinds of things. Everything we see on the screen here falls into like 2 or 3 categories for what kind of language it is. You know, what kind of problem it's meant to solve. All right, so you know, if we start over here on the website, and I'm going to breeze through this quick, okay? So Perl was a language that was based on C that was in existence kind of right in the early days of the internet. It existed before the internet. So we started using Perl initially for processing web scripts. Okay? Well, then we needed, once the internet became popular, we needed a language that lent itself to web stuff. Okay? Perl let us do memory, it let us ask questions, it let us do repetition, but Perl lent itself to problems. How many of you have heard of Perl before?
I have heard about Perl.
Okay. Do you know what kind of problem Perl lent itself to? Okay. It was for Unix system administrators. So if you're a Unix or a Linux system administrator, Perl was a powerful language for writing scripts. So it had a lot of tools in it for working with directory structures and user account creation, that kind of stuff. Sysadmin stuff. Well, now we needed a language that still did the memory stuff, still did the asking question stuff, still did the repetition stuff, but that lent itself to web type stuff, things that were common on the web. So PHP comes out, which is Perl for web. Still a C-based language. Those guys look similar to each other, but PHP has some extra tools built into it for allowing us to, if you have like a power saw, you can get different kinds of blades, and some are better at cutting through metal than others, that kind of stuff. Yeah, so this guy had the metal blades. He had the web blades. Make sense? So he had some stuff that made working with web stuff easier. Okay, but we solved it with Perl before that. PHP just made it easier. Okay, what did Ruby do for us? All right, so if we're just I'm going to talk about these at the high level because it'll take too long to put it out here on a slide. But one of the problems with web in the early days, if you were to look at a web page, if you were to right click on it and say view source, if a page was complex at all, you'd have this gigantic wall of crap. Okay, just tons and tons and tons and tons of code. Because when you think about a web page, there's two sides to it. We have the interface, and you have the logic. All right, so we pause here for a second. We're going to talk about design patterns. Did you talk about design patterns at all?
No.
Okay. And now we're actually starting to talk a little bit about what we're going to do in here, because we're going to be using Android in here. So we're going to talk about a couple of different design patterns. The first one is the design pattern, why is it escaping me? Give me a second for it. MVC. Have you ever seen that before? The phrase MVC?
Model View Controller.
Okay, so it stands for Model View Controller. All right, now you get to tell me what that means. Okay, now remember just a couple minutes ago I said that all of these funny buzzwords mean easy things, right? You were able to tell me what it stood for. And I promise you it stands for, it means something easy. But we don't know, right? I mean, yeah, isn't that all around us? I mean, I just bought a new TV a couple weeks ago. And I'm pretty up with technology stuff. But you go in and say, well, this TV has the HDR technology, and this one's an OLED display. And it's like, all I see is these 4 words and then $1,000 added on. Right? Or how many rupees is that? I mean, India's rupees, right?
Yeah, $1,000 too much.
Like a zillion rupees, right?
Yeah. It is going to be so cheap to travel India. It's like so cheap. The hotels, the travel. So.
Man, I had a student last year bring me in some money from India.
Oh,
I'm like, oh, well, this is really cool. And he said that's not even enough to get a candy bar.
It's like,
what kind of bribe is that? First of all, I'm low carb, and he didn't give me enough to buy a candy bar. That guy didn't pass. All right. So Model View Controller. Anybody know what that stands for? Or, well, we know what it stands for. Anybody know what that means?
View controller. Some kind of hardware into the model view controller.
So now you're just making crap up, aren't you?
I know that.
Is it like a control unit?
Control unit. Well, so usually you can't define things in terms of the words that.
I think it is a tool to develop a front end or interface for the website.
Okay. Yeah, I think we're starting to move towards it now. So if you think about any sort of user system, okay, a modern day user system typically has an interface, so something that sits between us and the computer, right? So I'm looking at the Mac OS interface here, right? All right, so that's the view. The view is the interface that human beings are going to work with. Okay, and then we have the model. The model is the database. That's the data stuff that's stored somewhere. So any problem we're solving has a memory associated with it, right? So how we model that memory is important, how we remember things, okay? The model is the memory, the view is what we see, the controller is the logic, okay? So model view controller is, basically says this: it's a good idea to separate the interface from the database from the logic. Keep those three things separate from each other. So a few minutes ago, I made the comment that if you looked at an old PHP page, what you would see is a gigantic wall of stuff. Because the way PHP worked is it was code that was embedded inside of HTML. Okay? It was embedded. How many do you guys know HTML?
Yeah.
Okay, we've done some HTML. Okay, you ready for a trick question? All right. So you're willing to bet your whole grade on this?
No. I think we will try, not but full grade.
Is HTML a programming language?
No.
Ah, tell me why.
Tag language.
It's a who?
Tag language.
Okay, it is true. It is a tag language, but why is it not a programming language? You answer pretty quick.
It doesn't have repetitions. We talked about no logic.
Yeah, I like it.
Conditions.
Yeah. Can't remember crap.
Yeah.
Can't ask questions. Can't repeat stuff, right? It's a data representation language. It's meant to represent stuff. It's a tag language, so it looks like a bunch of stuff with tags. It's used to give semantic meaning to data, right? So we can mark this as like somebody's first name or somebody's last name, that kind of stuff. That's where XML comes in, all right? So the fact that HTML is not a programming language means that if we're going to have web pages that do something, that do something dynamic, we probably need a programming language, right? What programming language is common on web pages? JavaScript, which by the way has nothing to do with Java. They just happen to share the name. They're not related. They're only related in that they both come from C. So JavaScript, this language exists because HTML can't do the programming stuff. HTML represents the interface, the view in the model view controller. HTML is what things look like, okay? And then CSS was the upgrade to that, right? Okay. Then our controller side of things would be like JavaScript or PHP, the logic. And then our database might be like MySQL or SQLite, something like that. All right, so now, have you heard of jQuery and Angular and React? Probably heard of jQuery at least. Heard of the? Okay.
But I haven't heard Angular and React. That's the first time.
Okay, these are the first time. Okay, so notice I have these guys right next to JavaScript. Right. This is not a programming language. This is not a programming language. This is not a programming language. You know what those guys are? They're JavaScript libraries. These guys are all JavaScript. They're just libraries that somebody wrote in JavaScript to automate stuff. So what does jQuery let us do? So this is the original saw. Here's the version 1 chainsaw. Here's the version 2 chainsaw. Here's the version 2.2 chainsaw. These guys are kind of competitors right here. This is Google, and this is Facebook. They're competing technologies that do the same stuff. Okay, so these are libraries written in JavaScript to allow us to solve certain kinds of problems. So if I'm just going to talk about this at the high level really quickly, a weakness of JavaScript in and of itself is when you have a web page and something changes on the web page, you have to reload the page. You have to refresh the page. Let me go ahead and actually insert something in here. Maybe you guys have heard of it.
HTML5 solves that problem?
That's true, but in a different way. Yeah, HTML5 is still pre-processed by the browser, so it still has to rely on JavaScript. But you are right. HTML5 is much closer to a programming language. because it embeds a lot of the stuff in it. So in the middle here, we had something called Ajax. So what Ajax was a JavaScript library that allowed parts of a web page to reload without having the entire page needing to reload. So as an example, if you're watching, let's see, you guys are probably cricket fans, right? Cricket?
Yeah.
We all like cricket? You just like pizza.
Soccer.
You like soccer? Like soccer, right? Football soccer, but not NFL football. Soccer, like kicking the ball.
Yes.
Okay, I got you. But you like pizza. All right, so what was I going at? What was it?
Ajax is
Oh, Ajax, yeah. So the idea is if you're on a web page and you're watching sports scores, you don't want to have to keep hitting the refresh button, right? You want to see the score flip on the screen, right?
Yeah.
Okay. Having a part of the screen update without having to have the entire screen updates is the bread and butter of Ajax. That's what Ajax does. All right. jQuery takes that to the next level. jQuery says, we're going to now give you a JavaScript library that makes it easy for the programmer to rewrite any aspect of the page. So what jQuery has is what's exposed to JavaScript is an object called a document. And you can walk through that document and update various parts of the page in real time. So you have a lot of granular control about what on the page updates. Make sense? Angular and React, this takes it to the next level. So these guys have things that relate to the database itself. When something changes in the database, something changes on the screen. Something changes on the screen, it changes in the database. Those two guys are bound. Okay, it's called two-way binding. Two-way binding. All right, but these guys are all JavaScript technologies right here. Okay, and what we can do is we can throw right underneath there that these guys are all front-end technologies. They all run inside the web browser. It's our web browser itself that executes those technologies. So JavaScript runs on the web browser. Make sense? These guys are all back-end. Okay? Now, what's another way of saying front-end and back-end? Can you give me a synonym for those?
View and controller.
So front-end sometimes is called client-side. All right? Versus server-side. Make some sense? All right, so these are our server-side technologies. These are our client-side technologies. These are our front-end technologies. These are our back-end technologies. They're all just words. They're all just phrases, right? Okay, so these guys would all live on the web server itself. These guys live on the web browser itself. Okay? So that's why a lot of form validation stuff, like if you're filling in a username and password on a web page, that's handled in JavaScript because now we're not sending your username and password to the server first. Instead, we're going to check to make sure you entered a username and password before we waste the server's time. Because if you have 5 million people with a computer, they're all trying to log into Amazon, you'd rather use a little bit of their individual computer's horsepower to check to make sure they filled out the web form before we waste the Amazon server's time validating them, authenticating them. Make sense?
Yeah.
All right, so we use client-side stuff to do things that, for performance reasons relative to the client, and also dynamically update the client's screen. Our server-side stuff is shared among all clients. So when we hit www.google.com or amazon.com and there's 5 million people that are all doing it at once, we're sharing one server. Amazon's a really expensive server farm, but we're all sharing that resource. Okay, instead of us having our own individual resources. So we need to be selective from a problem-solving perspective where we're going to put that stuff. Make sense? All right, so Perl was prior to the web. PHP was our first, we're going to say it's our first web-centric programming language, but it suffered from not having, in the early days, an implementation for MVC. So early PHP programs had all of the code, all the logic, and all the interface stuff all in one place. So it just looked like a wall of crap. What did Ruby do? Ruby, rarely does somebody say they're a Ruby programmer. Ruby always comes with an extra phrase after. What is it? Ruby on what?
Rails.
Ruby on Rails, right? Okay, Ruby on Rails. What's Rails? The cool kids, they don't say Ruby on Rails. They'll say, I'm really into Rails. A Rails developer. I'm just into Rails.
Rails is, I think, the platform or the Ruby server where you can Ruby on Rails.
Okay.
Yeah. The Ruby can only be programmed on that.
Ruby's just a language.
Yeah.
That's it. Ruby's a language. Just like C, just like C++, just like Perl. It's a language. It does the whole remembering crap, asking questions, repetition. Rails is a built-in web server. Okay? So PHP ran on a third, like Apache or Internet Information Server, which is Microsoft's web server. Ruby came with its own web server called Rails. So it solved actually two problems for us. One problem, if we're a PHP developer, what do we have to do? Well, you have to get a web server set up. You have to get the PHP plugin module working for it so that you can type in your code, and then you can upload it with FTP, then you can test it because you need to make sure it's testable with PHP because it's a server-side technology. So I'm going to write my code on my computer, I'm going to upload it to the server, then I'm going to test it on a web page which connects to the server. Hopefully it pre-processes the PHP and turns it into pretty pictures and text on my screen. Okay? But ultimately, in order to write PHP code, took some IT stuff, right? We had to have a whole setup to get our development environment going. Now, that's largely been fixed today because you can go out to like GoDaddy.com and for $5 you have a full PHP environment set up, right? And you can just go to town with it. Any web hosting site has PHP installed, all right? So PHP has stuck around because A, it's a very good language, it's very web-centric, but also because it's had lots of fans over the years that have built up infrastructure around it to solve some of these weaknesses, okay? Because in the early days, you would have had to create your whole environment. You would have spent a day just getting set up to write PHP code. What does Ruby do? Ruby comes with its own web server. Test it right away. Run it locally in your machine. As soon as everything's working the way you want, then you deploy it to the server up in the cloud somewhere. So that's one thing Ruby brought to the table with Rails. Okay, so it's packaged with the Rails server that automatically understands Ruby. It also has its own implementation of MVC. So Ruby comes, the Ruby on Rails model, there's a very specific directory structure you have to follow with Ruby on Rails that says you put all your interface stuff here, you put all your logic stuff here, you put all your database stuff here, and then they all seamlessly work together. Okay, so the downside of Ruby is that it's let's call it proprietary. You have to do things the Ruby way. The upside is you can generate dynamic websites pretty quickly once you learn the Ruby way. Make sense? Okay, so Ruby solved two problems. It solved the MVC problem, and it also solved the get up and running so you can start developing web stuff problem. Python, we're going to call that Python is just a language. I'm going to create another slide here because this is a good one. Competitors. So we're going to say PHP on Apache or IIS. So Apache is kind of if your web server is a Linux machine, you're running Apache. If your web server is a Windows machine, you're running IIS, Internet Information Server. This is the web server software that runs on those. Then we're going to have Ruby on Rails. Then we're going to have Python on Flask. Okay. Now the difference here is that Ruby on Rails kind of come packaged together. Those guys are they're a package deal. Where Python is a language, Flask is a third-party built-in web server that effectively allows you to accomplish the same thing that Ruby on Rails does. But Flask is just the web server, and then you would use something like maybe Jade for the model view controller side of things. So Rails is a web server plus MVC. Python, the Flask is just the web server. Jade would be an example of an MVC choice. What's nice about this is it's more modular. So over the years, if somebody comes up with something better than Jade, we can switch to that for our MVC implementation. For our a Jade is called a template engine, where you can write your interface in one place and you import it into your logic instead of having your interface and your logic intertwined.
All right.
Make sense?
Yes.
All right. So that's Python on Flask. This last guy here, we have Node.js. How many of you have heard of Node.js? You've heard that phrase before? It's the current cool kid on server-side technology. Anybody know what it is? It's probably too complicated. I just shouldn't tell you.
Node.js is again the same website as a development tool, but it interacts more with kind of, I think, with the servers.
All these guys are server. Every one of these guys is back-end server-side.
Yeah, more you create some kind of, I would say, how it will interact with the database, how the data is going to come, when request is going to get generated, and things like that.
Would we agree that these have been upgrades to each other? So we went from Perl to PHP on Apache to Ruby on Rails to Python on Flask. We kind of see a logic reason for going to this stuff, right?
Yeah,
Okay. So what we need to come up with, if we put ourselves in the shoes of the folks who are trying to come up with the next cool thing, what were they trying to do and why? I'm going to bounce back over here real quick. If you are a front-end developer, you're primarily working in two technologies, right? You're working in HTML and you're working in JavaScript, as well as all of JavaScript's fancy-sounding libraries. That's all those guys are. They're JavaScript libraries.
So Node is a collection of those libraries?
Huh?
Node is a collection of those libraries?
That's what they are. Ajax is written in JavaScript. It is a library called Ajax that has a bunch of JavaScript functions in it that make certain things easier to do. jQuery is built in terms of Ajax and then takes it to the next step. So it's JavaScript. Angular, also JavaScript. React, also JavaScript. These guys are all JavaScript. All right. So when you're a front-end developer, you're primarily working in HTML for making things look pretty, CSS for making things look extra pretty and consistent across a website. That's what CSS is for, right? Okay, it says, hey, you picked your color pattern, fine. All your pages reference the CSS, so if you decide to change your header color to purple, you just change it here and everything else falls into place. Make sense? That's the purpose of CSS. It's a power tool. It's Chainsaw version 2 for things looking pretty. So if you're a front-end developer, you're primarily working in HTML and JavaScript. Now, historically, the front-end people might be different people than the back-end people. Okay? These guys would typically be true programmers, let's say, the back-end people. The front-end people are kind of designer-programmer hybrids. These guys are good at making things look good, and then they have some programming skills as well. Okay? Now, generally speaking, if you're looking at jobs, wouldn't you say that there is a such thing as like a web developer where you're expected to do front-end and back-end stuff? You're expected to have both of those skill sets. Why should they pay for two people when they can get it in one? Okay? Well, since we said that these folks, the people who, we would agree that one of the most important things about a web page is that it looks good, right? It obviously has to work, but we eat with our eyes, right? So it has to look good first. So we really want the skill set of a designer who also has some programming experience. Now, even though all of us know, because we've learned in here, that programming is programming and the language doesn't matter, to a uninformed programmer, they might not be aware of that. They might look at it like, well, I only know JavaScript and Python seems so intimidating, or Ruby seems so intimidating, right? Okay. Node.js call that guy JavaScript on Node. The language is JavaScript. Node is the built-in server. And then you can use template engines like Jade and stuff like that with it. So what did they just do? I'm going to also put in here plus something called async. And we'll talk about that maybe after break. I don't want to kill you here. But I know we're trying to rush through some stuff, so you lose out on a little bit of break here. All I know is you're lucky to have me.
Yes, we are. No, it is true.
How can you make programming so exciting, right? See, the smile hasn't left his face. He's still wondering what what Portillo's is all about. Famous for chocolate cake. You eat chocolate cake? You don't even know what chocolate cake is, do you?
I know what
You like chocolate cake?
I,
Pizza? It's not, unless it's pizza, you don't eat it. Makes sense. All right. So one of the things here is these folks over here are very familiar with JavaScript. Why don't we go ahead and give them a less intimidating entry point into the back-end stuff by letting them write the back-end stuff in the same language as they're used to working with on the front end. Node.js, the base language is JavaScript, the identical JavaScript to that guy. Make sense? So even though we all know that the language doesn't matter, now these people who are designers who also program have an easier entry point into the server-side stuff. Okay? And then they have the asynchronous side of things. Okay? Have we all heard that phrase before, asynchronous? Async?
I know what asynchronous means, but I haven't heard that term in terms of this thing.
Okay. So let's go back here. Where's my design patterns? So there's MVC. Okay, so now we have the observer design pattern. All right. Anybody know what the observer design pattern? Have we heard that before? The observer design pattern? So kind of an important thing to remember here is, and this is academics invented this idea of design patterns because this sounds really formal, right? Oh, it's for people like me. Because you've heard the phrase publish or perish, right? Have you heard that phrase before? As an academic, we're supposed to write papers and research and stuff like that, right? Okay. I write a lot of software, so that's my publications. But point is that we invented design patterns. There's a couple rules for design patterns, right? Are you ready for this?
Yeah.
1, they have to have a funky name. MVC, observer. Another one we're going to talk about is something called a singleton. The singleton design pattern. Oh, that one must be impossible. I shouldn't even waste my time explaining it. Right? So, they got to have a funky name.
I think you taught us last time, but
So, general definition for design patterns is a proposed good solution to a common problem. Notice I have good and common in quotes. Good is in the eye of the beholder, right? And what's common? If you work for Lockheed Martin, maybe a common problem is consumption of rocket fuel.
okay, yeah.
Not something that we really care about, right? This guy cares about distance to closest Little Caesars. Probably Grafton.
2.3 miles from my home.
Here or back home?
Back
Okay, from here, you got one in Grafton. There's the Little Caesars in Grafton. So it's maybe 8 minutes in car.
I always have one in my car, so
Okay.
I have
I always keep a Little Caesars pizza that just quite hasn't rotted yet in my car, so I'm good to go.
I should be, it will be there not more than 2 days.
Well, I get it.
It's always good when I eat it.
I like this guy. I thought I was going to like you the best in here, but I like both of those guys better than you, actually.
I know that. The last time you were in last class, I was like, okay, I'm going to be the. Now I am so glad.
All right.
Okay, this is how we remain during this class.
Yeah,
Last time I was.
Fall asleep.
What's up?
All else will fall asleep if you don't.
Yeah, I think there's a real low chance you'd fall asleep in my class.
No.
That's why
Yeah.
promoting these conversations.
I'd like to think I'm pretty entertaining.
No, you don't like. I mean, you are.
Yeah, I mean, I'm funny. We get off topic, then we get back on topic, and we wonder, how the hell did this happen?
Connecting everything, and it's going on academics and subject. It's kind of speaking the algorithm and getting me to program.
So you're saying I'm a genius?
It's hard to say that.
Seriously?
All right. So observer design pattern, because we're talking about async, right? So observer design pattern, this guy says it's a good idea to be productive while we wait for some event to occur rather than stand there and wait. Okay? So if I'm going to do my famous roller skating demonstration, okay, you're all going to be waiting for me to fall, right? Okay? But rather than just standing there and just waiting, you know, is he going down? Is he going down? You'll know that I'm falling when you hear the scream, or at the very least the crash, right? Okay, because you can imagine somebody my size collapsing onto the floor makes some noise, right? Yeah, I mean it's true story. I guess this was probably 6 years ago. I got up in the middle of the night, but I got out of bed too quickly, and so you get lightheaded.
Yeah.
So now on my new policy, I sit on the edge of the bed for 10 seconds or whatever. But I got out of bed too quick. I was going to get a drink of water. So I pass out in the kitchen. And I had a glass in my hand, so the glass shattered, and so I didn't get hurt though. But I mean, I think I had like a bruise on my arm or something, but it could have been a lot worse. My neighbors heard me collapse, and I know I seemed petite.
So were you the same?
I was a big guy. Yeah, I broke my back when I was 18, and that's when I got big. I used to be almost a professional tennis player.
Really?
Yep. Played at University of Illinois in Urbana-Champaign.
So how long you have to be like on the back, like bad completely?
I was probably in pretty bad pain for a decade.
A decade?
Yeah. Well, it worked out. Had that not happened, I probably wouldn't have got a PhD. I probably would have tried to be a professional tennis player, living in my parents' basement. Could I have been the next Pete Sampras? Well, maybe. But there's a lot of people in the world that are really good at tennis, right? So, but I think that tennis talent translated into my golf. I'm a pretty good golfer.
I start learning. I already played 2-3 times now.
Okay.
Yeah. Now I know.
So we'll have to play for money.
First time I was like, why do you wear the gloves? And I don't know how to. And I started with this whole thing.
Because then you get the bug and you got to start practicing, and you start getting blisters.
It was painful.
I mean, I have a golf course in my house. I mean,
You're gonna have a match. You got a simulator.
I have a simulator in my house. Yeah.
So you were talking about money or something, and you were talking about.
He would lose.
Who knows? You're gonna bet some.
No,
I bet
I'm
on-
just
I
a
bet on
learner.
you. I'm just
I mean, I'm not good enough to play on the professional tour, but I play.
on simulator.
Oh no, I mean I play on Golf Channel Amateur Tour, and I've won tournaments.
It is not so easy because the way you hit it, you have to completely different. It goes completely.
Yeah, but the physics and stuff are amazing. I find it fascinating.
Otherwise, at the first I start hitting
The
it.
greatest game ever played.
What's this?
The greatest.
Oh, the
game
movie.
ever played. Yeah.
Yep.
That was
Yeah.
really interesting.
Hmm. True story.
Yeah.
Francis Ouimet is the guy. All right, so observer design pattern says it's a good idea to be productive. So if I'm doing my roller skating thing, you're going to go in, you're going to be working on your homework or doing whatever you're going to do, and as soon as you hear me crash to earth, okay, you'll then divert your attention over and observe the event you were waiting on. That makes sense? So instead of blocking, so synchronous problem solving would mean you stand there and you just wait for me to fall. Being completely unproductive, you're blocking, you're just standing waiting for an event, wasting your time. Asynchronous says we're going to go off and do something else, and then we're going to become notified when that event occurs. Okay? So something we're going to be dealing with in Android at some level. I mean, early on, we're going to be writing simple Android stuff, but at some point, we're going to have to deal with this idea of having more than one thing happen at once. If we think about this in a mobile application setting, when you open up an app on your iPhone or your Android device, things are loading off the internet, right?
Yes,
But
I
you
heard
still
that.
expect buttons to work,
Yes,
right? That's asynchronous.
I heard that term in like when there's a connection going on between server and client on a web page. An asynchronous packet is sent when the connection needs to be established or needs to be exited.
Yep.
I got the idea of async.
Okay. Yep. So that can make some sense, and it connects to our real life because we think something's broken. If we open an app on our phone and it's not scrolling and stuff, we think it's broken. It's crashed, right? And you kill it and reopen it. So that would be a synchronous application. If it's loading data in the background and it's just waiting until it has it all before it shows you crap. Otherwise, it's asynchronous where the data is being retrieved asynchronously. The interface works. It might not have all the crap populated yet, but stuff just starts popping in, right, as it becomes available. That's asynchronous. All right. So our observer pattern gives us that. So what Node.js brought to the table is JavaScript for server side and asynchronous stuff. Okay, that's what that guy brought to the table. All right, let's see. So
which of these languages right now then this Node.js and this JS would be the most used in the web developing rather than
on the server side, yeah. If you're building something brand new today for server side stuff, Node.js would be a pretty popular choice. This would be something the cool kids are doing.
So even Python or the other ones.
Python's still pretty popular, but Node.js would be your
best.
Best is the wrong word, because if you've been a Python developer for a while, Python is modular, so there are package managements. So really, what this comes down to, kind of a modern approach to these things, are things called package managers. So these are tools for easily integrating third-party add-ons to your project. So for Node.js, we have something called NPM. That's Node Package Manager. That's what NPM stands for. For Python, we have something called pip. Okay. Let's see. For iOS stuff, we have something called CocoaPods. So there's all sorts of different package managers. For Linux, we have something called apt-get. We also have something called yum. So there's all sorts of package manager things. Another thing you may have heard is called Bower. Bower is a package manager for web stuff. So lots and lots and lots of different package managers that help make our life easier. Okay? So my point of this little slide here is basically saying that Python is modern. Yeah, it's a modern language. It's a modern architecture. So if you like Python, that's the language you're used to working with, there isn't a great advantage to go over to Node.js unless you're going to be doing a lot of asynchronous event stuff, because Node.js lends itself to that. Okay? But if you're mostly doing just WebLogic stuff, if Python's your go-to move, I mean, if you're building a website using Node.js or Python, chances are for both of them you're going to use Jade as your template engine. The same product. One of them you'll say npm install Jade, the other one you'll say pip install Jade. The same package. Make sense? So, yeah, I would say try not to make any judgment calls as you look at this stuff as to which is better than something else, because they're all about the right tool for the job. Correct? So, for instance, we've been talking about chainsaws quite a bit, right?
Yep.
All right. So, obviously, as a human being, we always want to use the most powerful tool, right? Every time, 100% of the time. So you get your pizza from Little Caesars, and they didn't quite cut it very well. They were rushing. So I assume you go out to the garage, grab that chainsaw, make sure it's fueled up, right through the pizza and the table in the back seat of your car. We use like a normal little knife, right? Yeah, the right tool for the job. You don't bring a chainsaw to a pizza cutting contest. Okay? That makes sense? So at the end of the day, we want to use the right tool for the job. Okay, we run into that in IT all the time. So here in if you get a router, so here on campus, we're going to have night. How much do you think the routers here on campus cost? A lot?
$80 each.
No, I'm not talking about the Wi-Fi ones. I'm talking about the routers that run the campus network.
A lot.
A lot. They're expensive pieces of equipment, right? Okay. Now, a router is a router in terms of the problem it's solving, right? Okay. The difference is the grade of that router. So we can go over to Best Buy and buy a wireless router that's perfectly acceptable for the home, right? For $40. Okay. If you live in a home with a lot of like weird metal in the walls, you need a little bit better antenna. Maybe you spend $100 to get the better antennas for pushing out a better signal. And that's going to do just as good of a job in your home as a $10,000 router will, because it's a house as opposed to a giant enterprise type situation, right? So it's always about using the right tool for the job. More money does not equal better. Don't go spend 10 grand at your house for a router when you can get something that works for 40. Make sense? Okay. Don't use the chainsaw to cut your pizza. It's not the right tool for the job. Okay. It's a fun tool. It is a fun tool to use, but I guess whatever. Okay.
No, that was a better way of understanding.
All right. So package managers, design patterns. Okay. Let's. We're at a kind of a decent breaking point right now. Let's take. We can't take too long of a break because I still got more stuff to get through. So let's take about 10 minutes, and then let's come back and get through this so that we can jump into kind of where we're going with our first assignment. Sound good?
So all the things which are buzz or in the outside in the online or the people talking about, oh, this one is better than this one and this
Well,
one.
personal preference.
Actually, it is about what platform or what you are using when.
Yeah. Well, so you took up golf. That's like me saying, well, Callaway golf balls are better than TaylorMade golf balls. It depends on the person, right? Is a box of golf balls that's $40 a dozen must be better than a box of golf balls that's $10 a dozen. Depends. If you're Rory McIlroy, you're Tiger Woods, it probably is going to be better because those balls lend themselves to the better player. But for a majority of players, you're not going to notice the difference. Okay. If you've taken up golf, a good website to go to is a website called lostgolfballs.com. Yeah. Lostgolfballs.com. You can buy a bucket of 100 golf balls.
I got some golf balls in my house.
Actually, usually because the people sell it for $10, like they give that token and then they put in.
Oh yeah, that's for the driving range. I'm talking about if you go out and play. You go out and play to have your own golf balls you bring with you. Go on there, get Top Flight for a beginner. You'll get Top Flight golf balls. You can get 100 of them for probably $25. Yeah. And they're like, they've been used once. Somebody hit it off the tee, lost it in the woods. Somebody found it, took it to lostgolfballs.com, and that's the.
First, I was thinking kind of it is not